Welcome to Unit 6, Lesson 7, Electron Configurations. We're going to look at how to write electron configurations longhand and shorthand. So the electron configuration is showing us right here one way to show the electron configuration. In class we did practice using the boarding house or the hotel route, and we're going to kind of take that and put it, rather than drawing houses, we will use a linear way of showing where the electrons are. So chemists tend to use the notation called the electron configuration to indicate the placement of electrons in an atom. The lowest energy sublevel is written first, then the sublevels with increasing energies. We always start with energy level 1, and then we fill in the s orbital, and we will place a total of 2 electrons in the s orbital. The number of electrons in each sublevel is written as a superscript. So here we have 2 electrons, second energy level, s orbital, 2 electrons. Second energy level, p orbital, 2 electrons. We still have room to add additional electrons, however, carbon does only have 6. The electron configurations are a way that we distribute all of the electrons in an atom. They do consist of the number indicating the energy level. So this is the 4th energy level. The P will indicate the type of orbital, and the 5 indicates the number of electrons in that particular orbital. The periodic table is actually broken down into blocks. We fill orbitals in increasing order of energy. Different blocks on the periodic table then correspond to different types of orbitals. So the first 2 columns, those are the s block. The transition metals here in the middle are considered the d block. The p block is over here to the far right, and the f block are the 2 lonely rows down at the bottom of the periodic table. The periodic table, for example, the period 2 begins with lithium. I would recommend that you have a periodic table out with you at this point, and you need to reference it throughout the rest of this PowerPoint. So period 2 begins with lithium, which has 3 electrons. The first 2 electrons will be placed in the first energy level, the s orbital, and will place 2 electrons. With the 1 remaining electron, we will place it in the second energy level, and we will then place it also in the s orbital, and 1 electron will be in there. So after the 2s is filled, the 2 p orbitals are filled. 1 electron is placed in each p orbital before they are paired. The shorthand electron configuration uses a noble gas in brackets to represent the filled electron configuration of the noble gas. So if you look at your noble gases, they're column 18 on your periodic table, the very first one listed is helium. Helium has the electron configuration of 1s2. And rather than writing 1s2, we can write the abbreviation for helium, place it in the brackets, and then we take the remaining part of the electron configuration and add it to the end. So the helium, He, represents the 1s2. The 2s1 we would then just write beside. So how that kind of works is we were working with lithium. To find out the last noble gas we passed, we go up a row and all the way to the end. So we have helium. If we happen to be working with aluminum, we can use the noble gas electron configuration, and you go up a row into the end, and we would start with neon. The one really nice thing is, as long as you know the blocks, such as this is the P block here, the D block here, and S block here, and what row you are in, we can actually find out how and where to start our electron configuration. And we will do that with our practice. There are some irregularities according to the periodic table, and a lot of times it'll happen when we get down here into the D block. What happens is we should fill the s orbitals first and then d orbitals on a particular given row. Sometimes, for instance, the electron configuration for copper, which is Ar, last noble gas passed, and it is then 4s1 3d5, which seems